Elon Musk just broke free from China's rare earth stranglehold. Tesla's 2026 motor uses zero neodymium, zero dysprosium, none of the expensive metals every EV depends on. This could slash production costs by 25% and reset industry pricing overnight. But here's the real shock. How did Tesla solve the magnetic puzzle that stumped engineers for years? And when this motor hits mass production, what happens to competitors still chained to China's supply? The fallout could reshape the entire auto industry. Look, I've been covering Tesla for years, and I thought I'd seen every trick Musk had up his sleeve. But this motor? This is different. This isn't about making cars faster or adding flashy features. This is Tesla declaring independence from a supply chain stranglehold that has quietly controlled the entire EV industry since day one. Let me explain what's really happening here. Every electric motor in every EV, Tesla, BYD, Ford, everyone, depends on magnets made from rare earth elements. Neodymium, dysprosium, praseodymium. These aren't just expensive, they're geopolitical leverage. China mines 90% of the world's rare earths, and they've shown they're willing to weaponize that control. Back in 2021, when supply chains went haywire, China tightened rare earth exports and prices shot up 40% overnight. I watched EV manufacturers panic in real time. Production lines stalled, launch dates got pushed, and everyone realized they were trapped. Tesla saw that vulnerability and apparently decided the only way out was to eliminate the problem entirely. Here's what makes this announcement credible instead of just another Musk hype cycle. Tesla has been testing rare earth-free motors in Model Y units built at Gigafactory, Texas, since mid-2024. This isn't vaporware. Patents filed back in 2023 show a proprietary magnetic alloy using iron, carbon, and nitrogen arranged in a crystalline structure that mimics rare earth magnetic properties without actually using any rare earth elements. The magnetic field strength matches conventional neodymium magnets, but costs 60% less to produce. Tesla didn't just design around rare earths, they engineered new materials from scratch. That's the kind of vertical integration that separates Tesla from companies that just assemble parts from suppliers. What caught my attention even more is how this motor fits into Tesla's broader manufacturing strategy. The motor housing uses aerospace-grade composites that weigh 35% less than traditional metal frames. Now, weight reduction sounds boring until you understand what it actually means. A lighter motor needs less energy to spin. It generates less heat from friction. It puts less stress on bearings and mounting points. Tesla's internal data shows this composite structure alone improves energy efficiency by 15%. That's huge. That's either 15% more range from the same battery, or you can use a 15% smaller battery for the same range. Either way, costs drop dramatically. And here's where it gets clever. These improvements cascade through the entire vehicle. Heavy motors need beefy cooling systems, reinforced mounting structures, bigger inverters. By starting with a fundamentally lighter motor, Tesla shrinks all that supporting infrastructure. Smaller cooling system, less structural reinforcement, more compact inverter. When you add up these cascading savings across the whole vehicle, you start hitting that 40% cost reduction figure. It's not one breakthrough. It's rethinking the entire electric drivetrain from first principles. The thermal management system alone could solve one of the most annoying problems EV owners face. Anyone who has pushed a performance EV hard knows about thermal derating. You're flying on a track or climbing a mountain pass, and suddenly the car pulls back power to prevent overheating. It's frustrating because you paid for that performance, but physics limits how long you can use it. Tesla's new motor uses what they call liquid intelligence cooling, microchannels running through the motor housing with coolant that flows based on predictive AI algorithms. Temperature sensors feed data to a neural network that anticipates heat buildup before it happens and redirects coolant within milliseconds. Tesla claims this reduces heat generation by 30% and lets the motor hold peak power indefinitely. For Cybertruck owners towing heavy loads, that means no more power loss on long highway climbs. For Model 2 drivers, it means predictable range regardless of how you drive. Let's talk real numbers, because that's where this gets interesting. Tesla says the new motor delivers 20% more torque while using 15% less energy. The upcoming Model 2 with this motor will hit 60 in under 5 seconds, matching current Model 3 performance, while getting over 300 miles from just a 55 kilowatt-hour battery. Compare that to competitors who need 70 to 75 kilowatt-hour batteries for similar range. That's a $2,000 to $3,000 battery cost advantage before you even count motor savings. Stack those savings together, and suddenly a $25,000 Model 2 with healthy margins becomes not just possible, but probable. This is where things get uncomfortable for Tesla's competitors. BYD built its empire on battery cost advantages through LFP chemistry and massive scale. But if Tesla slashes $2,000 to $3,000 from motor and drivetrain costs while also needing smaller batteries, BYD's cost leadership vanishes. BYD faces an impossible choice: spend billions developing comparable motor tech, which takes years while Tesla captures market share, or fight a price war that destroys margins and possibly profitability. China already has over 100 EV manufacturers bleeding cash and fighting for survival. This motor could trigger consolidation that leaves half of them bankrupt. Toyota's situation is almost tragic from a strategic perspective. They bet everything on hybrids as a bridge technology, investing billions in systems that marry small batteries with efficient gas engines. It made sense when EVs were expensive with limited range. But if Tesla drops a $25,000 EV with genuine 300-mile range, why would anyone buy a $28,000 hybrid that offers maybe 50 miles of electric-only driving? Toyota's solid-state battery program won't reach production until 2027 or 2028. That's a brutal 2-year window where Toyota watches Tesla capture millions of first-time EV buyers who then stay in the Tesla ecosystem forever. We saw this exact pattern with smartphones. Once someone commits to iPhone or Android, they rarely switch. Toyota's hybrid strategy, once praised as prudent and pragmatic, could become their blockbuster video moment, correct until suddenly catastrophically wrong. The American automakers face perhaps the harshest reality. Ford and GM stake their electric futures on trucks: F-150 Lightning, Silverado EV, Hummer EV, all using expensive rare earth motors and massive battery packs. If Cybertruck with Tesla's new motor undercuts them by $15,000 to $20,000 while offering better range and towing capacity, these flagship programs could hemorrhage money. Both companies already surrendered the charging infrastructure battle by adopting Tesla's NACS connector. Now they might need to license Tesla's motor technology just to compete. The alternative is watching their most profitable segment, trucks, get destroyed by a company that didn't even make trucks 5 years ago. What fascinates me most is the strategic trap this creates. Competitors can't just copy Tesla's tech quickly. Rare earth-free magnets require material science expertise that takes years to develop. Composite motor structures need manufacturing capabilities most automakers don't have. The thermal management AI needs massive real-world data for training. Even if competitors started crash programs today, they're looking at 3 to 5 years before production readiness. Meanwhile, Tesla produces millions of vehicles with this motor, refines manufacturing, drops costs further through scale, and builds an insurmountable experience advantage. There's a twist here that most analysts miss. Does eliminating rare earth dependency weaken China's leverage over EVs? Yes and no. China's rare earth monopoly loses value, but China's EV manufacturing dominance could actually strengthen. BYD, Geely, NIO have state backing, aggressive engineering talent, and manufacturing speed Western automakers can't match. They also operate where IP enforcement is, shall we say, flexible. Once Tesla's motor reaches production, Chinese manufacturers will reverse engineer it within 12 to 18 months. They'll integrate it into their vehicles and potentially undercut Tesla in China itself. Tesla might escape rare earth dependency only to hand Chinese competitors the blueprint for the next evolution. The environmental math deserves honest examination. Eliminating rare earth mining removes genuinely ugly practices from Tesla's supply chain. Rare earth extraction produces radioactive waste, poisons water supplies, and often involves labor conditions that are basically modern slavery. Engineering around these materials eliminates real moral and environmental problems that have undermined the EV industry's sustainability claims. But Tesla's expansion still requires massive lithium mining, ethically questionable cobalt extraction, and enormous manufacturing energy consumption. The net benefit depends on efficiency gains. If this motor truly cuts energy use by 15% to 20%, and electrical grids keep moving toward renewables, then each Tesla built with this motor generates about 30% lower lifetime emissions than conventional EVs. Scale that to 5 million vehicles by 2030, and you're looking at 50 to 70 million tons of CO2 reduction annually. That's like permanently removing 10 to 15 million gas cars from roads. Now, about that 2026 timeline. Elon Musk's predictions have a complicated relationship with reality. Cybertruck was supposed to launch in 2021. It arrived late 2023. Full self-driving has been next year since 2016. Should we believe 2026? Here's why I think this one is different. Tesla has been running these motors in production vehicles since 2024. Patents were filed in 2023. Gigafactory Mexico is under construction specifically for next-gen platform production. The technology isn't conceptual. It's being validated in real-world conditions right now. The question isn't whether Tesla builds this motor, but how fast they scale from thousands to millions of units. My honest prediction? First Model 2 deliveries hit customers in Q3 2026, not Q2. Initial production reaches maybe 75,000 units in 2026, ramping to 400,000 through 2027. Cybertruck gets the new motor mid-2026 as a running change. Model 3 and Model Y refreshes with new motors roll out gradually through 2027 and 2028. This is aggressive but achievable based on what Tesla has actually demonstrated, not what Musk promises. Does this change everything? Not overnight, but by 2028 or 2029, the EV industry will be unrecognizable. Either Tesla dominates through superior economics, or competitors catch up through desperate innovation spending that destroys profitability. The middle ground disappears. Rare earth-dependent motors become obsolete. EV costs drop 20% to 30% industry-wide. Mass adoption accelerates beyond current forecasts. The real question isn't whether this motor matters. It's whether your favorite automaker has the financial strength, engineering depth, and manufacturing flexibility to survive what comes next. Some will adapt and thrive. Many will fail. And the industry that emerges will barely resemble what exists today. So here's the bottom line. Tesla's 2026 motor eliminates rare earth dependency, cuts production costs by 40%, and forces every automaker into an impossible choice: match Tesla's economics or exit the market. This isn't incremental improvement. This is Tesla resetting the entire industry's cost structure overnight. But the bigger story? When EVs become cheaper than gas cars by 2026, the global auto industry hits a point of no return. Combustion engines become economically obsolete, not just environmentally outdated. That's the real revolution hiding inside this motor announcement. And Tesla's not stopping here. This technology scales to semi-trucks, roadster, future models we haven't seen yet. By 2028, we'll know which automakers survived this transition and which became cautionary tales in business school case studies. Now I want your take. Which competitor do you think has the best shot at catching up? Can Toyota's solid-state batteries save them? Will Chinese manufacturers reverse engineer this faster than we expect? Drop your honest predictions in the comments below. If this analysis gave you clarity on what's actually happening in the EV industry, hit that like button. Subscribe to Tesla Zone for deeper breakdowns on the innovations reshaping transportation. And turn on notifications so you catch our next video when Tesla's next bombshell drops. Because with Musk, there's always something coming. The EV revolution just accelerated. The question is whether the rest of the industry can keep up.